The purpose of this project was to send commands using a serial terminal to the microcontroller, as well as using Bluetooth to communicate between a microcontroller and smart device. UART is a universal asynchronous receiver, transmitter frequently used in communication between computers. We are to become familiar with the concept of the UART and ways to communicate through serial interface such as real-term, PuTTY, teraterm, and so on. First we will get into the first microcontroller's necessary components. The PLL.C file utilizes the onboard crystal to enable a clock and set the bus frequency. This module is required to use timers effectively in the grand scheme of the project. The bus frequency is set to 50 MHz. All timers and interrupts on this project will use this designated frequency. The UART.C file sets up and enables the UART connectivity on the TM4C. UART_nchar outputs the ASCII code from the UART receiver module. UART_outchar grabs an 8-bit ASCII parameter and sends the data to the UART transmitter module. UART_outstring uses UART_outchar iteratively in order to transmit an entire string. UART_newDEC receives an ASCII character and converts it into a readable 32-bit unsigned number. UART_outUDEC grabs a 32-bit unsigned input number parameter and converts it into a readable digit 09. UART_newX accepts an unsigned hexadecimal input and converts it to a 32-bit unsigned number. UART_outUX grabs a 32-bit unsigned input number parameter and converts it into an unsigned hexadecimal format. UART_nstring accepts ASCII characters from the serial port and adds them to a string until enter is typed or the maximum length of string is reached. The UART_C.C file sets the UART to interface the two microcontrollers. The UART_BT.C file sets up the communication line between MCU1 and the Bluetooth module. MCU uses pins PD6 and PD7 to communicate UART signals. The port.C file initializes port F pins for output. It sets the PWM for the onboard blue LED. The artist_main.C file contain the main method. In this method, the UART and UART_BT modules were initialized and configured. Our group changed the Bluetooth's baud rate, key, password, and name. Afterwards, this Bluetooth module was designated slave mode. This mode is how information is passed from the Bluetooth module on a smartphone to this microcontroller and vice versa. This file also contained a second main method. In this method, we show a message for the user to choose between sending information to the speaker or onboard blue LED. With this message, the user expected to send a F or B, followed by a baud rate. If the parameters are out of bounds, the user is asked to re-enter the input. Now we will get into microcontroller 2's files. The PLL.C file utilizes the onboard crystal to enable a clock and set the bus frequency. This module is required to use timers effectively in the grand scheme of the project. The bus frequency is set to 50 MHz. All timers and interrupts on this project will use this designated frequency. The UART_test.C file troubleshoots on the PC serial terminal. This is done with a wired USB connection that communicates data from the MCU2 to the PC serial terminal. The DAC.C file creates an 8-bit digital to analog converter. This is done with pins PB-PB7. The reoccurring samples are taken using a SysTick clock. The port.C file initializes port F pins for output. If a green LED is displayed, MCU2 is working. The artist_main.C file contains the main method. In this method, we call and configure all of the dependent modules. We also grab information from MCU1, and either stop or return sound through the speaker. In conclusion, this project served well in helping us become familiar with the concept of the UART and ways to communicate through serial interface such as real-term, PuTTY, teraterm, and so on. The input from the smartphone was able to communicate using Bluetooth to the first microcontroller. Then, the second microcontroller grabbed that data through UART communication and sent that data into a DAC which sent output to the speaker. The noise the speaker made depended on the signal that the phone sent.